Hey guys, this is the video for the 12.02 notes. If you have any questions, you can always message me on Remind. And remember, you should be watching these videos before our live chats on Tuesdays. That way you can ask me any questions you need before you start your homework. Okay, so let's get started. Probability. That's what this whole unit is about. What does that actually mean? So remember, probability is a number from 0 to 1, indicating the likelihood of an event. Okay, so again, it's a number from 0 to 1, indicating the likelihood of an event. What is the chance that that is going to happen, that an event is going to happen? So your answer is always going to be a number from 0 to 1. So it can never be a negative number, so it can never be less than 0, and it can never be bigger than 1. It always has to be between 0 and 1, and it can be written as a decimal or as a fraction. Normally, I will write it as a fraction, so just so you know, that's how we're going to write it. And remember to always reduce your fractions. So when an event is guaranteed to happen, it's definitely going to happen no matter what, the probability is 1. 1 means that is guaranteed to happen. There is no chance that it's not going to happen. This event will happen every single time. When an event is guaranteed not to happen, its probability is 0. That means it will never, ever, ever happen. No chance at all. So the closer something is to 0, the less likely it is to happen. And the closer something is to 1, the more likely it is going to happen. Let's look at example 1. A bag contains 6 red marbles, and you want to draw out a marble from the bag. So it has 6 red marbles in it. Let's first find the probability of red. So a probability problem always has a P in the front and what you're trying to find the probability of on the inside. So red, there are only 6 red marbles in this bag. So what's the probability of getting red? That probability is 1. It is guaranteed to happen. There is no chance I'm going to pull out a purple marble. It's got to be red every single time. It's guaranteed to happen. What about the probability of pulling a blue marble? Since there are no blue marbles in that bag, it is guaranteed not to happen. There is no chance I'm going to pull out a blue marble. So that probability is 0. Okay, there are 2 types of probability. So experimental probability is the probability that something actually occurs in an experiment. What I mean by experiment is, I mean that you are physically doing this event. So if I'm talking about what's the probability of flipping a coin and getting heads, we know that there's a 50-50 chance of getting heads and tails, right? Now, if you were to actually flip that coin 100 times and document how many times you got heads and how many times you got tails, you may not get 50 heads and 50 tails. You may get 40 heads and 60 tails. So 40 out of 100 would be your experimental probability, or 60 out of 100 would be your experimental probability, because that is what you physically got. That's not what we typically think of, but when I actually did the experiment, that is what I got. That probability is your experimental probability. So theoretical probability is when you actually do the math. When you divide the number of outcomes of an event by the total number of all possible outcomes. And the formula for that is listed here. The number of outcomes for event A to happen would go on top, and the total number of all the possible outcomes would go on the bottom. So going back to our coin example, when you think of 50-50, or if you're trying to find the probability of heads, there's only one heads out of a total of 2 sides of a coin total, we know that probability is 1/2. I don't have to physically do it to find that. That is your theoretical probability. When you were just asking yourself, okay, how many of these are there out of the total number? That's your theoretical probability. Let's try an example. So a bag contains 3 red marbles and 2 blue marbles. I want to draw a marble from the bag. There are 3 red marbles total. So if I'm trying to find the probability of red, the total number of outcomes of that event is 3, because there are 3 red marbles. Out of how many outcomes total? Well, there are 5 total because there are 5 marbles. So the probability of getting red would be 3/5. 3 red marbles out of the total 5 marbles. What's the probability of getting a blue marble? Here there are 2 blue marbles out of how many marbles total? 5. So the probability of getting a blue would be 2/5. Now I want you to notice that in this problem, there are 3 red marbles and 2 blue marbles. We can only get red or blue marbles. So let's look at our 2 probabilities for red and blue, since those are the only things that could possibly happen. Let's add those together and see what we get. If I add 3/5 the probability of red plus 2/5 the probability of blue, that gives me 5 out of 5, which is 1. And what does 1 mean? 1 means something is guaranteed to happen. So this tells us that I'm guaranteed to get a red or a blue because those are the only 2 things in my bag. So with any event, if you were to add up every single outcome's probability together, since you have to pick one of those outcomes, all of those outcomes added together would equal 1 because one of those things is guaranteed to happen at some point. So that's just kind of a way to check yourself. Okay, moving on to a complement. A complement is all the outcomes that are not the event listed. Okay, so here you can see it's got a little tick mark on it. This means I want to find the probability that A does not happen. Okay, so you could see that again as an A with a little tick mark. You could see it as an A with a little C for complement, or you could see it as an A with a line over it. Pretty much any little extra something you see on that event means that you're actually not finding the probability of A, you're finding the probability that A will not happen. So again, to find the probability that A will not happen, the complement of A, I'm going to take 1 and subtract the probability that A does happen. So let's think of why that would be true. So why am I subtracting it from 1? Remember what we just talked about over here. If I were to add all possibilities together, that probability would be 1. So this means everything put together. If I have everything and take away the probability of A, I would be left with the probabilities that are not A. So let's look at example 3. I know the probability of A is 3/4. So what is the value of the complement, the probability of the complement of A? So the probability of the complement of A, or the probability that A does not happen, would equal 1 minus the probability of A, which would be 3/4. So remember 1 is 4/4, and if I subtract 3/4, I get 1/4. So the probability that A does not happen is 1/4. Okay, example 4. When flipping a coin, what will be the complement of heads? Now notice I didn't ask what the probability of it is. I'm just asking what is the complement. So if I have heads, its complement, what is not heads, would be tails. You just write the word tails down. I didn't ask for the probability. I'm asking what is the complement. The complement is tails. Okay, so I've said the word events a lot. So let's talk about those a little bit. You could have mutually exclusive events, or you can have overlapping events. So mutually exclusive events are events that cannot happen at the same time. Events that cannot happen at the same time. They cannot happen at the same time. Overlapping events are events that can happen at the same time. Okay, so now we're talking about or. When you see the probability of A or B, what you're going to do is you're going to take the probability of A and you're going to add that to the probability of B. But sometimes you're going to have to subtract the overlap, is what I say. If there is overlap, if they are overlapping events, you have to subtract that overlap. So you're going to subtract the probability that A and B overlap, which means that they happen at the same time. You're going to have to subtract that away. So why is that true? And to talk about that, I think the easiest way is to picture a Venn diagram. So everything that's inside of this circle is A. Everything that's inside of this circle is B. And what overlaps in the middle is A and B happening at the same time. So if I'm trying to find the probability that A or B will happen, I'm going to take the probability of A, everything inside that circle, including the overlap, plus the probability of B, which is everything inside the B circle, including the overlap. So what just happened there? If you add these two circles together separately, you just added that overlap twice. I can't count numbers twice if I'm trying to add all the possibilities together. So in that case, I'm going to have to subtract one of those sets away. I'm going to subtract the probability of A and B. That way it's only counted one time instead of twice. So that's why we subtract that overlap. So a lot of times your overlap is going to be 0, which means that there is no probability of A and B, there is no overlap. And in that case, that means that you would have mutually exclusive events. If that probability is 0, there is no overlap. That means that these cannot happen at the same time, which means these are mutually exclusive events. If you do have a probability here, if there is overlap and you do have a probability for A and B happening at the same time, then these are overlapping events. So let's look at example 5. First, I want to find the probability of 1 or 3. So you don't have to write this down every time. I'm going to write it down for the first one. I want to find the probability of 1 plus the probability of 3. And then I also want to subtract the probability that 1 and 3 will happen at the same time. So that's the formula that I'm kind of following in my head. So first, what's the probability of getting a 1? If I'm talking about a dice, which if that's a number cube, remember that's a dice, and a dice or a number cube has 6 sides total, which means we're going to have 6 numbers. So the probability of getting a 1, there's going to be 1 1 on that number cube out of 6 numbers total. Plus, what's the probability of getting a 3? There is 1 3 out of 6 numbers total. Now I need to think about 1 and 3 happening at the same time. If I were to roll a dice, is there any way that I can roll a 1 and a 3 at the same exact time? The answer is no. So what's the probability of 1 and 0 happening? 1 and 3 happening? That probability would be 0 because there is no chance that when I roll that dice that I get a 1 and a 3. Now you just add those together. 1/6 plus 1/6 minus 0 would be 2/6. Always reduce your fractions, which is 1/3. Okay, so before we move on, is the event of rolling a 1 and the event of rolling a 3, are they mutually exclusive events or are they overlapping events? So think about that for a second and answer that question for me. Is the event 1 and 3, are they mutually exclusive or are they overlapping? The answer here is that they are mutually exclusive because they can never ever happen at the same time. The probability of 1 and 3 happening at the same time is 0, which means that they cannot happen at the same time, so these are mutually exclusive events. Okay, now let's move on and let's try the next one. Here I want to find the probability of a 4 or a 5 or a 6. First, what's the probability of getting a 4? There is 1 4 out of 6 numbers total. Plus, what's the probability of getting a 5? There is 1 5 out of 6 numbers total. Plus, what's the probability of getting a 6? There is 1 6 out of 6 numbers total. We are not done yet. Don't forget to consider that overlap. Minus. Can I ever get a 4 and a 5 and a 6 all at the same time? The answer is no. I can never roll that dice and get a 4, 5, and a 6 at the same exact time. So we are subtracting the probability 0. It can never happen. So what's 1 6 plus 1 6 plus 1 6 minus 0? That is 3/6. Reduce your fraction. So the probability of rolling a 4, 5, or 6 is 1/2. So again, are these mutually exclusive events, 4, 5, and 6, or are they overlapping? The answer is that they are mutually exclusive. They can never, ever, ever happen at the same time. Okay, let's move on and let's look at a 2 or an odd. Excuse me. Okay, so first, what is the probability of rolling a 2? There is 1 2 out of 6 numbers total. Plus, what's the probability that I could roll an odd number? Let's look at all the numbers all together. I could roll a 1, 2, 3, 4, 5, or 6. How many of those are odd numbers? 1, 3, and 5 are all odd numbers. So the probability of rolling an odd number is 1, 2, 3 odd numbers out of 6 numbers total. And again, we're not done yet. I now need to subtract what's the probability that I roll a 2 and an odd number at the same time. So here are my odd numbers. Pretty much you're asking, are any of these the number 2? Since 2 is not an odd number, and no odd numbers are the number 2, those two things could never happen at the same time. So that probability is 0. There are no numbers that are 2 and odd at the same exact time. So 1 6 plus 3 6 minus 0 is 4 6. Reduce that to be 2/3. Again, are these events mutually exclusive or are they overlapping? The answer is mutually exclusive again, because again, these events could not happen at the same time. So there was nothing to subtract. Okay, last number on this set. I want to find the probability of getting an even number or a factor of 30. What's the probability of getting an even number? Let's go back to our list. Here are all my numbers. How many of those are even? So 2, 4, and 6 are all even. So 3 numbers are even out of the 6 numbers total. Plus, we want to know what's the probability that I could roll a factor of 30. First, let's think about what are my factors of 30. So first I get 1 and a 30. I could get a 2 and a 15, 3 and 10. 4 is not a factor of 30, so I go to 5, and that pairs up with 6. And then we have listed all of our factors of 30. Now, is it possible to roll all of these numbers on my dice? The answer is no. I could roll a 1, 2, 3, 5, or 6 on a dice, but I cannot roll 10, I cannot roll 15, and I cannot roll 30, so I'm not going to consider those numbers. So the numbers that are factors of 30 and also could be on a dice are 1, 2, 3, 5, and 6. So how many numbers are factors of 30? 1, 2, 3, 4, 5 numbers are factors of 30 out of the 6 numbers total that are on a dice. 4 is the only number that is on a dice that is not a factor of 30. Okay, again, we're not done. We now need to subtract the probability of getting an even number and a factor of 30 at the same time. Again, all of these numbers are my factors of 30. Are any of these numbers also even? The answer here is yes. 2 is a factor of 30 and an even number. And 6 is a factor of 30 and an even number. So there are 2 numbers that are even and a factor of 30 out of the 6 numbers total on a dice. Now again, the reason why we are subtracting them is because 2 and 6 were counted in the even numbers. 2 and 6 were also counted in the factors of 30. I don't want to count them twice, so I need to subtract one of those sets away. So 3 plus 5 minus 2 is 6 out of 6. And what does 6 out of 6 reduce to? 1. And what does the probability of 1 mean? That means it's guaranteed to happen. When I roll a dice, I'm guaranteed to either get an even number or a factor of 30. It could even be both at the same time. Every single number that you roll on a dice will fall into one of those categories. It's guaranteed to happen. Okay, last problem we're going to talk about is the back, example 8. So this table below shows the names of students in Miss Bodega's class who do or do not like Zaxby's and Chick-fil-A. Here are all the students who like Zaxby's, all the students who like Chick-fil-A, all the people who like Zaxby's and Chick-fil-A. These are all the people who do not like Zaxby's. So again, since we have this category, Zaxby's and Chick-fil-A, just keep in mind that these are the only people who like both options. These students over here who like Zaxby's, that means they like Zaxby's, but they do not like Chick-fil-A. And these people listed here like Chick-fil-A, but do not like Zaxby's. The only people who like both are listed here for Zaxby's and Chick-fil-A. And then Abdur and Chloe do not like Zaxby's or Chick-fil-A at all. Okay, so let's set A be the names of students that like Zaxby's, and let's set B be the names of students who like Chick-fil-A. We want to list the set of students for each question. There's no P's in the front, and it did not ask us to find the probability, so your answer should not be a number here. You are actually listing the set, which means you are writing out the students' names who fall into that category. So who are the students who like A and B? Who of the students like Zaxby's and Chick-fil-A? So go through each category. If you were to go up to Gracie and say, hey Gracie, do you like Zaxby's and Chick-fil-A? Think to yourself, what would they say? Gracie would say, no, she only likes Zaxby's. So she is not included in Zaxby's and Chick-fil-A. Hey, Cassandra, do you like Zaxby's and Chick-fil-A? She would say no, because she only likes Chick-fil-A. The only people who would say yes to that question would be Diamond, Lauren, and Mason. Those are the only students who would like both. When you see the word and, it always means both. What is the probability of both of these things happening? These are the students who like both Zaxby's and Chick-fil-A. Okay, now let's look at A or B. Okay, so these are all the people who like Zaxby's or Chick-fil-A. So that would be all the people who like Zaxby's. So if you went up to Gracie and said, hey Gracie, do you like Zaxby's or Chick-fil-A? She would say, yeah, I like Zaxby's. So all these people would be included. Okay, so or Chick-fil-A, all of these people would be included because they like Chick-fil-A. Okay. Now, is that everybody that we would want to include? If you were to go up to one person in all these categories and ask them, do you like Zaxby's or Chick-fil-A? And they would say yes, did you write all those people down? So again, we wrote down this category, we wrote down this category. Now let's talk about Diamond, Lauren, and Mason. If I went up to Diamond and said, hey Diamond, do you like Zaxby's or Chick-fil-A? What would Diamond say? She would say yes, I just happen to like both. So you actually are going to also include in this answer Diamond, Lauren, and Mason. So I know what some of y'all are thinking. Why are we adding in those students when in our formula we're supposed to subtract the and? And the reason why is, let's go back to that Venn diagram. We have the circle of A. Everything inside of the circle is the probability of A. Everything inside of this circle would be an event B. So we can think of everybody in A liking Zaxby's and everybody in B liking Chick-fil-A. The people in the middle like both A and B. They like Zaxby's and they like Chick-fil-A. So if I want to know who likes Zaxby's or Chick-fil-A and you're following that formula, you're adding all of A, including the overlap, plus all the B, including the overlap, which means that you just added that overlap twice. So in our formula, you would then subtract one of those sets so that only one of the ands is included, not two of the ands. So the and is included. We need to add that in because one of those sets needs to be included. In our formula, we subtract it because it got counted twice. Here, we only counted it once, so we are good to go. There is nothing to subtract. If that's confusing for you, just message me on Remind or ask me on our live chat, and we can talk about it some more. I know it can be a little bit confusing for people. Okay, last. C looks exactly like B, except for this little tick mark here, which I know can be hard to see. But what does that mean? That means the complement. And what does complement mean? It means not A or B. Who does not like Zaxby's or Chick-fil-A? And that's going to be easy. It's over here. It's Abdur and Chloe. Okay, that's the notes for 12.02. Make sure you do the 12.02 homework before it's due on that Tuesday. Make sure you've done these notes and you gather any questions that you need before our live chat. So yeah, if you have any questions, message me on Remind. Have a good day.